In one of the laboratories of Cambridge in 2018, a young geneticist by the name of Daniel Svensson sat in front of a monitor and could not understand what he had just seen. In front of him were the results of a comparative blood analysis, tens of thousands of samples gathered from all over the world, from the Bushmen of the Kalahari to the Yakuts, from Icelanders to the inhabitants of Easter Island. And somewhere in that vast table a single line was blinking, one he had double-checked 4 times in a row. There was only one match with the ancient samples. Only one. Not a group of peoples, not a region, not a continent. A single people, of all those living today, carried in their veins the blood that had flowed through the veins of human beings who died 30,000 years ago. Svensson would later say in an interview with a German newspaper, "I thought it was a machine error, and then I realized it was an error in my notions about humankind." To understand why this discovery turns everything upside down, let's first sort out what a blood group actually is from the standpoint of science. Most of us know 4 letters, A, B, AB, and O, plus rhesus, plus or minus. There the school curriculum ends, but the real picture is far more complex. On the surface of red blood cells there are dozens of different antigens, tiny protein markers that work like a barcode. Modern medicine distinguishes more than 40 blood group systems, not 4, 40. And each of these systems is, in essence, a fingerprint of how our ancestors changed over hundreds of thousands of years. Blood is an archive, only it is written not in words, but in molecules. And so, when scientists began to dig into this archive, they realized a remarkable thing. Blood groups are not a random assortment of biological details. They are a marker of migrations, the very barcode by which you can read where your lineage came from, what diseases it passed through, under what conditions it survived. For example, it is believed that the second group, A, appeared about 20,000 years ago in those regions where people had already begun to transition to a settled way of life. The third, B, somewhere around Central Asia, among the peoples who kept livestock and drank milk. The first, O, is considered the most ancient and the most simple, like the base version, the firmware on top of which everything else was later built. And the first thought that comes to the researchers is a simple one. Since O is the most ancient, then our direct ancestors, the ancient sapiens out of Africa, must have had the first blood group, which means that the closest to them today should be those peoples who have the highest share of O carriers. Logical? Logical. For a long time, this version was considered almost an axiom, and the first thing the scientists did was to look at the Indians of South America. There, the percentage of the first blood group is off the charts. In some tribes, it reaches 98. Even 100%. 100. An entire people with a single blood group. It would seem, here it is. Here they are, the direct heirs. But this is precisely where the first trap is hidden. The first false trail along which genetics tramped for several decades. When they began to look deeper, not at the letters A and O, but at that very grid of 40 systems, at the rare antigens, at the molecular signatures, it turned out that the Indians of the Amazon do not at all resemble the most ancient samples. Their pure first group is not an inheritance from forefathers, but the result of a catastrophe. When the Europeans came to the Americas, they brought with them smallpox, measles, influenza, and these diseases mowed down the carriers of other blood groups almost to nothing. Those who had the second or the third died faster. Those who had the first survived more often. This is not antiquity. This is a bottleneck 500 years old. Nature squeezed the population dry, left a single letter, and we took that for a monument to the past. But the monument turned out to be fresh. Then the scientists set off on a second trail. The logic was this: if the Indians are a late optical illusion, perhaps direct heirs should be sought among those who never went far from the ancestral homeland. Among the African peoples. And here the second trap sprung almost immediately. Africa is not one Africa. It is a continent on which the genetic diversity of human beings exceeds the rest of humankind put together. When the blood of the San, the Pygmies, the Hadza, the Nilotes, the Bantu was compared, it turned out that the differences between them were greater than between a Norwegian and a Japanese. That is, to look for the ancient core in Africa is the same as looking in a library for the first book ever written. There are too many of them, and they are all ancient. By pure statistics, not one of these peoples matched those particular control samples from 30,000 years ago. And now, this had already become a serious problem. A guy from Voronezh, 28 years old, who is listening to this story right now, may fairly ask, well, all right, the Indians did not fit. The Africans did not fit. So where did they look then? And the answer begins to sound unexpected. The third hypothesis, which for a while seemed almost insane, was that direct heirs should be sought where no one had been thinking to look. Not in the tropics, not in Africa, but there, where 30,000 years ago, people were precisely battling for survival in the harshest conditions of the Ice Age. In Europe, more precisely, in its oldest corners, the ones that the waves of later migrants did not reach. The scientists once again picked up their test tubes. They compared samples of ancient blood reconstructed from skeletal remains found in caves on the territory of present-day France, Spain, and southern Italy. And it was then, for the first time in this story, that a narrow but real lead appeared. Among modern peoples, one region gave a statistically significant match across several rare antigens, not on a single letter, no, on a whole set. And that region turned out to be the Basque country. The Basques, a people who live on the border of Spain and France, at the foot of the Pyrenees, a people whose language is not related to any other language of Europe, not Indo-European, not Finno-Ugric, not Turkic, none. For 100 years, linguists have been breaking lances, trying to understand where in the world this language even came from. A language spoken today by about 1 million people. Basque is, in essence, a shard, a linguistic relic that has survived all invasions, all empires, all the migrations of peoples. When the Romans were building their roads, the Basques were already speaking it. When the Celts came to Europe, the Basques were already there. When the Indo-European tribes rolled in wave after wave, gradually turning the continent into the map of modern languages, the Basques sat in their mountain valleys and went on speaking the way their grandfathers and great-grandfathers had spoken. And when the researchers peered into their blood, it turned out that the Basques carry within themselves the highest percentage in Europe of that very rare combination of antigens, which is found in the ancient samples. They also have an unusually high percentage of negative rhesus factor, which on its own is considered one of the oldest traits. Among the Basques, about a third of the population has negative rhesus. For comparison, among Slavs it is about 15%. Among Asians it is less than 1. This is not an average figure. This is a statistical outlier, a molecular relic. But here too, as in any honest investigation, one has to slow down, because a match on several antigens, all by itself, is not yet proof of direct kinship. It is only a reason to dig deeper. And so when, already in the year 2020, a large international group carried out full sequencing, comparing the mitochondrial DNA, the nuclear genome, and the blood groups of the Basques with those very control samples from the Paleolithic sites of Europe, there a whole fan of matches converged. This stopped being a coincidence. This became a picture. The picture looks like this. About 25 to 30,000 years ago, at the very height of the last glacial maximum, Europe was almost uninhabited. Enormous glaciers covered the north of the continent. Living was possible only in a few narrow strips in the south, on the territory of present-day Italy, the Balkans, and southwestern France, together with northern Spain. These zones are called glacial refugia, refuges. There people waited out millennia of cold, pressed closely against small patches of land where trees still grew and game still ran. Most of these populations later, after the warming, either intermixed with new arrivals or were displaced entirely. The farmers from the Middle East, 10,000 years ago, came to Europe with wheat, barley, and herds, and almost completely rewrote the genetic code of the continent. And then came the Indo-Europeans out of the steppes, and rewrote it again, and again, and again. Except for one place, except for one valley, where the new waves, for some reason, did not reach, or did reach, but broke against the mountains and against the people who already lived there. The Basques are, in essence, a preserved fragment of that same Ice Age Europe, which has practically nowhere else survived, and their blood comes from there, and their language comes from there. And, perhaps, even certain features of the face that anthropologists have long noted, those too come from there. And here is the strangest turn of the whole story. Think about it for a moment. It turns out that the carriers of the most ancient connection to those very sapiens who lived at the junction of the Paleolithic and the Mesolithic are not some mysterious tribe from the jungle, not hermits on islands, not Amazonian Indians, but perfectly ordinary Europeans, with passports, with bank cards, with favorite TV series and a game of golf on the weekends. A schoolboy in Bilbao, a little girl in San Sebastian, a sailor in the Bay of Biscay, they carry in their blood a signal that breaks through 30,000 years. They themselves may not even know it, and they walk past us on the streets of Spanish and French cities, carrying within them a living archive of humankind. And here is where one wants to linger. Because in this discovery, there is something genuinely moving. We are used to thinking that the past is something separate from us, that the Paleolithic is a museum. It is drawings in caves. It is a skull lying under glass. It is something that we study the way one studies what is foreign. And the science of the last few years is saying ever more loudly something different. The past has not gone anywhere. It is dissolved in us. It pulses in the veins of specific people who, right now, at this very minute, are riding the metro, feeding their children, arguing with their boss. The archive is open. It is just that its pages are written in a language we have only just learned to read. And if you, listening to this story right now, are catching yourself on the thought, and what is my blood group? What does it say about me? Whom does it remember? Share it in the comments. Write your group, and rhesus. Write where your family comes from. Together, let's put together a living map of which relics are hiding inside each one of us. And if this topic resonates, put a thumb up and subscribe. We will go on to break down how blood tells the story of the migrations of the Slavs, the secrets of the Siberian peoples, why the Japanese have almost no negative rhesus, while some Tibetan tribes have an antigen that is found nowhere else in the world. This is not dry biology. This is a detective story 30,000 years long, and we have only just begun to understand something in it. But before I finish, there is one detail that I deliberately kept aside. It is important. That very laboratory of Svensson's, with which I began, after the publication of the first data, received several alarmed letters. One of them came from Argentina. A private researcher wrote that in his small settlement in the north of the country, there lives a group of descendants of Basques who had migrated there back in the 19th century. And among them, according to his data, was the same rare blood profile as among their kin in Europe. That is, the blood had not been diluted. It had not spread out across the world over 5 generations of life in a different climate, in a different environment, among different peoples. It holds on, the way a language holds on in a family, in which the grandmother stubbornly speaks to her grandchildren in the native tongue. Blood turned out to be just as stubborn a keeper of memory as words. And in this, perhaps, lies the main lesson of the whole story. We are used to looking for the ancient far away, in the pyramids, in caves, in forgotten tribes on the edge of the map. And it turns out that the ancient lives very close, in an ordinary person, in his silent cells, in an invisible barcode that he carries, and about which he has most likely never given a thought. And when such a person simply gives blood at his district clinic for analysis, what ends up in the test tube is not only today. There are 30,000 years of history. It's just that no one usually looks closely. Daniel Svensson, that same geneticist from Cambridge, at the end of the same interview said a strange thing. The journalist asked him what he felt when he understood what he had found. He answered like this: "I felt that humankind is much more finely connected to itself than we think. We are not different peoples scattered across different continents. We are one story, which simply has different chapters. And in each chapter there will always remain someone who continues to remember the beginning." someone in whom the first line is still sounding. Today it is the Basques. Tomorrow, perhaps, we will find in the blood of other peoples other lines, even more ancient still. Of one thing I am certain, there will be many more such finds, and each one of them will remind us of the same thing, that we all came out of one door, and that this door is still open.